All right. Hi, guys. How's it going? So today we're going to talk about binary ionic bonds. So up to this point, we've talked about ions and that ions are atoms that lose or gain negative particles. So those are the positives and negatives that we've been talking about up to this point. So in order to find the charge for an atom for groups 1A through 8A, you look at the top of each column, and then the labeled charge indicates the ion that will be formed. So you guys all have periodic tables right now that tell you the charges for these atoms. But like I said, on your test, the periodic table you're going to be given is not going to have these charges. So you're going to need to remember that 5A is -3, 7A is -1, 1A is +1, so on and so forth. All right. So if we were to make the following ions, let's just do a little review. If we needed to make oxygen, oxygen is O. It is a member of group 6. So if it's a member of group 6, it's O -2. We were looking at barium. Barium is down here. Barium is a member of 2A, so barium is Ba +2. Potassium is a member of 1A. Here's potassium, so that is K +1. And iodine is over here. Iodine is a member of group 7, so it is I -1. All right, so now we're going to talk about bonding. So what happens with these ions here is atoms are going to lose or gain negative charges to form bonds. And the first type of bond we're going to talk about is an ionic binary compound. And in the word binary, binary means two. And ionic are the ions, positives and negatives. So this word actually means that we're going to be dealing with two ions and two ions in a compound. So what it is it is a compound or compounds composed of a cation, which is positive, and an anion, which is negative. All right, so over here, in order to form a binary compound, there are a couple of steps we're going to take to do that. The first step is to write the cation with its charge. So with these two compounds, we have lithium and bromine. Which one is the cation? Which one is the anion? Well, if we remember, cations are positive. So if we find lithium, lithium is here in group 1, it's +1. So we're going to write down Li +1. Bromine is the anion. So the next step here is to write the anion with its charge. So we got to find bromine. Bromine is here. Bromine is a member of group 7, so it is bromine -1. All right. Now it says calculate the number of cations and anions needed to make the charges add up to 0. Well, if we have +1 and -1, what happens to these two charges? They already cancel. So +1 -1 cancel, which means I only need one lithium to one bromine to make my compound. That's it. Now let's take a look at potassium and oxygen. Potassium is K +1, member of group 1. Oxygen is O -2, which we already did right here. So now if I have +1 -2, do these cancel? No, they don't. So what I need to figure out is I need to figure out which one I need more of in order to get them to cancel. Well, if I have -2 and +1, I'm going to need another positive to cancel out my negative. Can I change the charge of potassium to 2 just because I want to? The answer is no, because potassium is a member of group 1. It can only have a +1 charge. So instead of changing the charge, what I can do is I can have an additional potassium. So if I do that, I have 2 positives to cancel out my 1 -2. Well, then what I need to do is I need to count how many of each of these ions I have. I have 2 potassiums, so I'm going to use this little thing down here called a subscript to denote how many potassiums I have. And I only have 1 oxygen. So here's my compound. So if we were to look back at it, I have 2 +1 potassiums and I have 1 -2 oxygens. Now notice how when I put things in a compound over here and over here, I am no longer writing the charge. I do not need to include the charges in the compound because the charge is now equal to 0. All right, let's take a look at aluminum and sulfur. Aluminum is over here, member of group 3, so aluminum is +3. Al plus 3. Sulfur is over here, a member of group 6. So sulfur is minus 2. Okay, so like I said, we cannot change the charges. Once we have the charges written down, we cannot change what they are. I can't change this to a negative 3. I cannot change this to a positive 2. But what I can do is I can change the number of ions that I have in order to get things to cancel. Well, we did one of these in our example yesterday with the activity we did in class. And in order to get a plus 3 and a negative 2 to cancel, I need to find the common number. And that common number is 6. So what could I do to turn this aluminum to a positive 6? Well, I could add another aluminum, and that would be a total charge of plus 6. And what could I do here? If I wanted to make this a negative 6, I would need 2 more sulfurs, which is a total charge of negative 6. And what happens to positive 6 and negative 6? That gives me a total net charge of 0, which is what I want. So then what I need to do is I need to look at, okay, how many aluminums do I have? There are 2 here. So I have Al2. And how many sulfurs do I have here? I have 3, so it's S3. So what this little subscript denotes is I have 2 aluminums. This subscript denotes that I have 3 sulfurs. 2 positive 3s cancel out 3 negative 2s. All right, last one is calcium and oxygen. Calcium is a member of group 2, so it's plus 2. Oxygen is a member of group 6, so it is minus 2. All right, and here I have plus 2, minus 2. What happens? These two cancel each other out, so I just need 1 calcium and 1 oxygen to make my compound because they cancel each other out. Now, notice how I am not putting little ones here, because if there's a 1, you do not need to write it in your subscript. All right, so that's how we form compounds. The next part is naming an ionic binary compound. So now what we're going to do is we're going to be naming them. So first thing we're going to need to do is we're going to need to name the cation by using the element's name from the periodic table. So all metals, all cations, they keep their name. So for example, in this example, we have barium and fluorine. Barium is the cation, it's positive. Fluorine is the anion, it's negative. So barium is going to keep its name, barium. Then the next step is to name the anion by taking the root of the element's name from the periodic table and then adding "ide." So what we're going to do is we're going to drop the ending, I think would be a better way to put it. So if we have fluorine right here, fluorine, we're going to drop the ending, we're going to drop this INE, and we're going to turn it into fluoride. And that is the name of the compound. Over here, we got to figure out who's the cation, who's the anion. Aluminum is our cation. Nitrogen is our anion. So the metal, the cation, gets to keep its name, which is aluminum. And nitrogen, we're going to drop the ending. Nitrogen is a little goofy. It's not going to become nitroide. It's going to become nitride. That's just one that you're just going to have to know. Okay, so we drop the O-gen, we add ide. Sodium and phosphorus. Sodium is our cation. It's a member of group 1. Phosphorus is our anion. It's a nonmetal, so that helps. Sodium keeps its name since it's the cation and the metal. And phosphorus is not going to become phosphoride, because most people would assume we would drop the us. We're actually going to drop the orus as well, so it becomes phosphide. And if you were to write phosphoride on a test or a quiz, I'm not going to take off points. I get it. But phosphide is the actual correct way to write it and to name it. All right, last but not least, we have potassium and arsenic. Potassium is a cation, plus 1. Arsenic is a nonmetal. It's an anion. It's on the nonmetal side, even though it's a metalloid. So potassium is going to keep its name. It's the cation. And arsenic, what do you think arsenic is going to become? Well, it's going to drop the ick, and you're going to add ide. So anytime we have a compound with a nonmetal, you're pretty much going to drop the ending of these words, and you're going to add ide. So carbon becomes carbide, nitrogen becomes nitride, oxygen, oxide, fluorine, fluoride. phosphorus, phosphide, sulfur, sulfide, chlorine, chloride, arsenic, arsenide, selenium, selenide, bromine, bromide, iodine, iodide, tellurium becomes telluride, and astatine will become astatide. We probably won't use this one, but it's there. So most of these are the ones that are going to be used as the anion for a non-metal or a metal non-metal compound, or an anion, cation anion compound. All right. Now what you guys are going to do is you're going to work on the worksheet that goes with it. Maybe do every other, maybe do every single one, check, and make sure that you understand what you're doing. And that's it.